right, gang, this is the start of a new chapter, chapter 9, and the title of this chapter is Stoichiometry. Big word, Stoichiometry, stoichiometry. Stoichiometry is the relationship between two compounds in a balanced chemical equation, either from their masses, or we can talk about it in terms of moles. In the past, we've looked at doing mass mole particle conversions, and this is tied to that. So this is like, instead of doing mass to mole conversion for just an element like nitrogen, now we're doing mass mole conversions from compound to compound. So we define stoichiometry as the relationship between two compounds. And we should probably, I'm going to do a little caret in here, insert this. Oh, we're talking about mass mole relationship. So for example, for the equation, if I take aluminum and I react that with sulfuric acid, I'm going to get aluminum sulfate, and the formula for that will be Al2SO4 3 and hydrogen gas. When I balance, I need a 2, a 3, a 1, and a 3. And that balances me. So for example, if I start off with, I don't know, 1,000 grams of aluminum and 500 grams of sulfuric acid, and I want to know how much aluminum sulfate I can make. I want to know the mass of aluminum sulfate that I could form. We use stoichiometry for that. We said in the chapter on mass mole particle, we had a chart, and I'm going to do part of this in pencil, so you might want to see what I do before you copy this into your notes. So we had mass, we had mole, and then down here, I'm going to put this in pencil. We had count as a number of atoms. And I'm actually going to erase this. It's in pencil, so we're just going to erase it eventually, because we're not worried about, we're not going to do anything with particles in this chapter. So if I start with, if we were looking at aluminum sulfate and I had the mass of that, I could convert that to the moles and I could find out how many atoms. Actually, in this case, it would be molecules, how many molecules that would be. Well, what if I want to compare my sulfuric acid to my aluminum sulfate? Now I have two different compounds. And so I would have, shoot, I should have done this. We'll call this compound A, and we'll do green because green means go. And we'll call this compound B, and we'll call that what we're solving for. So if I start with so many grams of this and I want to know how much of this I could form, start, stop, how do I do that? Well, let's say this is the mass of A, and let's say this is the moles of A, which is sulfuric acid. Over here, I have mass mole conversions, and so here I have the mass of B, and I have the moles of B, and I could put in count if I wanted to. But like I said, we're going to ignore that. Well, it turns out there's another conversion factor that I can use to connect these two. And that new conversion factor, and this is the name of it up here, is called a mole ratio. So between the moles of two different compounds, I have a mole ratio. So I apologize. I really should have flipped this, and I'll you know what? Tell you what, I'll redraw it. But let's take this out. So we're not going to use this at all. So for this chapter, we're not. You guys had this handy dandy diagram. So if we were going to redraw this, and I was going to draw it correctly from left to right, I would have the mass of A. And I'm going to go to the moles of A. And then I've got the mole ratio. Of A to B. Then this takes me to moles of B and mass of B. And when I say B, I'm talking about compound B. So this is a better way to draw that diagram here. So if I want to convert from moles of this to moles of this, all I have to do is use the mole ratio. If I want to go from here to here. If I want to go, though, from the mass of this to the mass of that, I have to convert mass to moles. Then I have to convert to moles using the mole ratio. Then I have to convert back to mass. And that's what we're going to work on. Now we're going to build this in steps. But before we do that, we have to look at what a mole ratio is. In the past chapters, when we looked at coefficients, we said that coefficients were equal to the number of molecules. So for example, if we looked at one atom or one molecule of sulfuric acid, H2SO4, we would say it has 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen, and I have 3 molecules of that. Well, that's actually not the best way to talk about our coefficients. And in fact, our subscripts also, it's not necessarily the best way to talk about them in terms of number of atoms. These numbers can all represent moles. And so what we want to say now is that the better way to talk about these coefficients is the number of moles. Well, what do I mean by that? Another way I could read this equation, and I'm going to write it out in word form, is that 2 moles of aluminum react with, that's with, 3 moles of sulfuric acid to produce 1 mole of aluminum sulfate and 3 moles of hydrogen. So our mole ratios are the ratio of the moles of compound A to the moles of compound B. So in this case, the mole ratio of sulfuric acid to aluminum sulfate sulfuric H2SO4 to Al2SO43 would be 3 to 1. The way we're going to write that is 3 moles of H2SO4 to 1 mole Al2SO43. Remember, this is now a conversion factor. Conversion factors can be flipped. I could also write this as 1 mole of Al2SO43 to 3 moles of H2SO4. If I wanted to write the mole ratio between aluminum and hydrogen, so let's say we're going to do aluminum and hydrogen, I would have 2 moles of aluminum to 3 moles of hydrogen, or I could say I have 3 moles of hydrogen to 2 moles of aluminum. Okay, what is the mole ratio between aluminum and aluminum sulfate? Did you say 2 moles of aluminum to 1 mole of aluminum sulfate? If you did, that would be correct. And you can write that as this conversion factor. All right, let's do a practice problem before we end the video. And let me go back to light blue. So let's say I have, oops, decomposition reaction. Okay, so when what you're going to do is you're going to write the mole ratio between mercury 2 oxide and mercury, mercury 2 oxide and oxygen, and mercury and oxygen. So go ahead and pause the video and write out those mole ratios. Great. So hopefully, welcome back. You wrote 2 moles of mercury oxide to 1 mole of oxygen, and that could be flipped. You could say 2 moles of mercury oxide to 2 moles of mercury. And you could say 2 moles of mercury to 1 mole of oxygen. So those are all of the possible mole ratios we can get out of this equation. And what we're going to do is we're going to use those. If I'm starting with, let's say I have 2 tons of mercury 2 oxide, and I want to know how much mercury I can make and how much oxygen I can make. I can do that calculation, but I have to use these mole ratios. This is the linchpin between your first compound. And remember this, so let's do a takeaway here. So this is our first video in stoichiometry, which is a relationship, mass mole relationship between 2 compounds. And if I have a balanced equation, I can look at the relationship between any 2 compounds. So in this case, compound A is sulfuric acid and compound B is aluminum sulfate. But the connector between those 2 is going to come from these coefficients in the form of a mole ratio. So mole ratio is the relationship, let's define that. It's just basically the ratio of moles between 2 compounds that comes from the coefficients. And we did some practice problems. We looked at some mole ratios up here, and then we did a practice problem down here. All right, let's start to put this to work in the next video.